Hello, everybody. Happy Friday. Sorry I'm out again. One of my bestest girlfriends is getting married this weekend in Ohio, so I am off to her wedding. Today, you're going to be learning how to find the volume of spheres. This should be pretty easy to learn, especially through a video, being it's just a formula. So again, remember, I am not going to be reteaching on Monday, so please make sure to pause the video, rewind the video, listen to the video, take notes with the video, because again, you will be held accountable for all of the material. That being said, what I would do first is I would go ahead and pause the video and try the warm-up on your own. The warm-up is given a cone was sliced in half, find the exact volume of the solid. That would be my advice. Here we go. My welcome back. For those of you who just came back, I need to find the volume of a cone. So I know that my volume of a cone formula is area of the base. My shape of my base is a circle times my height or my inside height divided by 3, because as I stack that circle, it gets smaller and smaller. I need to find my quantities. My radius would be 5 because my diameter is 10. So I have 5 squared pi. My inside height is this right here. It is not my slant height. That's actually a triple. And divide by 3. So now I compute. It says exact, so I'm not going to push the pi button. 5 squared times 12 divided by 3. And I'm finding my answer to be 100 pi. However, I only have half of that, so obviously I need to cut it in half. So that's giving me 50 pi, any units? Units cubed. And again, that's how many little cubes can fit inside of my cone. All right, so next, there we go. Today we're going to do the volume of a sphere. So what we're going to do first is we're going to watch a little video about how we can take a sphere and divide it up into other shapes. Let's see, can I find that video? There we are. Here we go.
4 over 3 pi r cubed gives you the volume of a sphere. But where does the formula come from? First, we'll draw a perfect sphere and fill in its volume. Next, we will divide the sphere into equal-sized pyramids with square bases. So let's take a look at one pyramid, and remember that its volume is equal to 1 over 3 area of the base times height. Now let's quickly show that the height of all the pyramids that make up the sphere is actually equal to the radius. So our equation becomes 1 over 3 area of the base times radius. And we will simplify this equation by replacing radius with r and area of the base with b. We will be numbering the bases, so we start with base 1, and our equation is base 1 r over 3. So in order to find the volume of the sphere, we simply have to calculate the volume of the pyramids and add them together, giving us a simple formula. So lining up the pyramids, we start from the beginning, and we have volume of the sphere is equal to base 1 r over 3 plus base 2 r over 3 plus base 3 r over 3. And we will continue this process up until the last pyramid. Now we don't know how many pyramids we have, so we just let base n r over 3 simply represent the last pyramid. So having added up the pyramids together, we have this complete simple formula to work with. So next, we will use algebra and begin by factoring out a 1 over 3, and we will also factor out the radius, giving us r over 3 times the sum of all bases. So now let's concentrate on the sum of all bases, and remember, these are the bases of the pyramids that make up the sphere. And as you can see, the bases actually form the surface area of the sphere. So, the sum of all bases is equal to the surface area, which is equal to 4 pi r squared. Now, a quick explanation for why the surface area is 4 pi r squared is first we'll look at our sphere and take its largest possible circumference. With that circumference, we'll make a circle. And now the amazing fact is the surface area of the sphere is equal to exactly 4 times the area of the circle. The area of each circle is pi r squared. Combine them together and we get 4 pi r squared. So now let's go back to our simple formula and replace the sum of all bases with 4 pi r squared. Now we combine the r's together to get r cubed, and now we simply rearrange the equation to get 4 over 3 pi r cubed. So 4 over 3 pi r cubed gives you the volume of any sized sphere that exists.
All right, thank you so much for that, sir. So now, if I go back to our notes, all that's saying is that in order to find the volume of a sphere, we're going to basically say that the volume of a sphere formula is the area of the base. Well, the base ends up being all of these guys, right? That would be our base, which actually ends up being the surface area. So therefore, of a sphere, so it would be 4 r squared pi's times the height. The height of these pyramids actually ends up being the radius of the sphere, so times the radius. And then again, we divide it by 3 because we're looking at it in terms of pyramids. And then if I go ahead and I do a little bit of algebra, he's getting 4r cubed pi divided by 3 is our formula for a sphere. Now, my hope is that if we do a hemisphere is half of that. And so half of 4 is 2. So our hemisphere formula is just like the other one, but it would be 2r cubed pi divided by 3. Unfortunately, I'm not there for it. So for the last time, I feel the need to summarize. All right, go ahead and grab your summary sheets. And mine is, I thought I had it all ready for myself. Nope, it doesn't look like I do. Let's go back. There it is. All right, so my formula for a sphere volume right over here is, again, my volume for a sphere will always be 4 times r. And here's what, again, cubed, not squared, cubed pi divided by 3. If you need to, your volume of a hemisphere, which again is half, would be 2r cubed pi divided by 3. So the way I like to summarize this is just to kind of point out to you guys that the only quantity you need for spheres is your radius. You need your radius, whether it's being surface area or volume. All right, let's go ahead and put these into work today. Let's get started. So my first question says, determine the exact volume of a sphere with a diameter of 10. So again, volume of a sphere is 4 times radius cubed pi divided by 3. If my diameter is 10, that means my radius is 5. So I'm going to go ahead and do 4 times 5 to the 3rd power pi divided by 3. Let's see, do I have that app on my iPad? I do. I want to show you guys something, which I think is kind of nice. There we go. If you hit your second y equals button, it actually will get you your fraction, which is really, really nice. So again, all I did was, one more time, I hit second. Oops, I don't think I hit, second y, nope, I lied. Oops. Alpha y equals. One more time. Alpha y equals will get you your fraction. So here we go. I'm going to do 4 times 5 to the 3rd power. Arrow down. Divided by 3, enter. I'm getting that. So one of my answers could be 166.6 repeating pi, or I can hit math, enter, enter, and that will also give me an exact answer. So my two answers, either one would work. Let's go back here. So I got, my volume is 166.66 repeating pi, or I would accept 500 pi over 3 meters cubed. Both of those are valid answers. Okay. Next one, given a hemisphere attached to a cone where the slant height of the cone is 10 and the radius is 6, determine the exact volume of a figure. Again, remember we've talked about this. With volume, we can speak in 3D. So I'm going to find the volume of my cone, and then I'm going to add it to the volume of my hemisphere. Again, I like to write down my formula, area of the base times the height divided by 3. Hemi would be 2 times radius cubed pi divided by 3. So basically, if I can just find these quantities, I'm going to be in good shape. My slant height is 10. That's my surface height. My radius is 6, which means my inside height would have to be 8 because it's because of my triples. So if I go ahead and scroll down, I'm just going to go ahead. Area of my circle is radius squared pi times my inside height, which is 8, divided by 3, plus 2 times radius cubed, 6 cubed pi, divided by 3. Again, if you go into your math equals, your calculator, here we go. Oh, I'm going to do it on my calculator this time, only because I can't see if I clear it. So here we go. Again, you can use that alpha y equals if you like that. Here we go, alpha y equals. I like that a big time. So I like to do 6 squared times 8 in my numerator, divided by 3 in my denominator. I'm getting this first one to be 96 pi. When I do alpha y equals again, I'm going to have 2 times 6 to the third power. Again, that's always a mistake, divided by 3. I'm getting 144 pi, and I can add those together, and I'm getting 240 pi inches cubed as my final answer. Again, it says exact, so I did not touch the pi button. Okay, I can't even read. The volume of a sphere is 9 pi over 2 centimeters cubed. Determine the exact circumference of the great circle. Okay, so first thing I do is I kind of look at what I'm given. I'm given the volume, so I know my volume of a sphere is 4 times r cubed pi over 3. Again, they gave me the volume, so I actually know this quantity. So I'm going to write 9 pi over 2 equals 4 times r cubed pi over 3. Now, there's lots of different ways you can solve this. You can even make 9 over 2 4.5 if you really want. I'm a big fan of cross multiplication. It's something we've used all year, so I'm going to use that method. So if I cross multiply, I'm going to get 27 pi equals 8 r cubed pi. I'm going to divide both sides by 8 pi. 27 divided by 8 is nothing nice. So now I have r cubed equals 27 over 8. All right, I want to, again, show you your calculator. So the way we get the third power is we third root it, because that's its inverse, right? Inverse of squaring a square root. So the third root. So where is the third root? Well, if you go into your calculator, lots of things lie in your math button. So if you hit your math button, you'll see the cubed root. So that's number 4. So I'm going to do the cubed root of 27 divided by 8, enter, and I get 1.5. Again, I went to my math button and I looked in there and it's number 4. So I am getting my R to be 1.5. All right, now I'm going to go answer the question. They want the circumference of the great circle. Well, the great circle is just a circle, so I need my diameter. So therefore, I am getting, if my radius is $1.50, my diameter is 3, so 3 pi centimeters. That would be the circumference of my great circle. And finally, last but not least, real life problems. We actually use spheres a lot in the world. Determine the volume of empty space in a box containing 3 golf balls that fit snugly in the box. The diameter of each ball is 2 inches and round to the nearest thousandth. So I want to figure out how much empty space. So again, I have to speak 3D. So I'm going to find the volume of the prism and get rid of the volume of the 3 spheres. Right? That will tell me how much empty space I have. So the way I find the volume of a prism is I just do area of the base times the height. The way I find the volume of spheres is I'm going to do 3 times 4 times r cubed pi over 3. Okay, so right now I don't really know much. I just know my diameters, which means my radii. So I could kind of fill this in. I know that I have 4 times 1 cubed pi over 3, right? And if I go to my box, I know that this is 2, this is 2, this is 2 because of all those balls in there, right? Again, if you think about a box, if I kind of go like that, right? That's my 3D box. So therefore, I know the depth of my box is also 2. And then the width of my box is also 2 because those are just diameters. So if I look, this box is actually a 6, right? So I know the area of my base. The area of my base would be 2 times 2, which is 4. I'm making the base the bottom. You can make whatever you want. Times the height of my box, which is 6. So, unless I screwed up, let's see. The depth of my box is 2. Across my box is 2. I think that's right. So then now I'm questioning because the teacher whose key I'm looking at is not getting what I'm getting. 2 by 2 by 2, 2, 4, 6. The depth is 2. The width is 2. So I am getting that this is a 4 by 6 and a 4. Nope, I'm right. I win. So therefore, I'm getting that this would have a volume of 24 inches cubed. And then depending on how you do this algebra over here, I'm just going to go ahead and do that because those cannot get rid of each other. So now I'm left with minus, and 4 times 1 cubed is just 4. So I'm going to get 4 pi. So basically that's going to give me the volume of empty space, but it does say round because if I leave my answer like that, I have no idea what 24 minus 4 pi is. It doesn't really make sense. So I'm going to actually do that, 24 minus 4 pi, and I'm getting it to be approximately 11.434 inches cubed. So if you actually think about this, the box had 24 cubic inches and 11 of it is empty space. That's a lot of empty space. So these are things that people have to think about. Like, should we make a cylinder box? Would that be less empty space? Is it more affordable to make a cylinder box? Which is easier to package when we ship them. All of those, if you're looking into marketing or maybe working in a company, these are the kinds of decisions some people have to make. But just for our class, the empty space is 11.434, which is almost half of that box, which is kind of neat. All right, so today was the volume of a sphere. The volume of a sphere formula is 4 times radius cubed pi divided by 3. Again, a hemisphere, I just do 2 r cubed pi divided by 3. Number one mistake is remembering this. It's r cubed, not r squared. And again, I always tell kids because of volume. That is it. My ask of you now is to go ahead and you can pull out your IP, get some of that done. At this point, you can do problems 7, 8, and 10 today. You pretty much can do almost everything 1 through 10 if you'd like to try those, so you can knock that out. You have a test on Thursday and a formative on Tuesday. I hope you all have a wonderful weekend, and thank you for listening. Have a great